Good afternoon. I'm Conrad from EOXPLORE.
I'm Gunter from Terranea.
And we are, we'll be presenting the hazard information services built with open data.
Yeah. Why hazard information services? I guess we are all used to such photographs. Just a few days ago or still ongoing, Hurricane Matthew, devastating Haiti, affecting other Caribbean islands, Florida. We had just a few months ago the earthquake in Italy. And to manage such events, information is paramount. And we also need very much geographic information to get through such crisis situations. However, while here in the Western world we have plenty of sensors, tools, satellites and so on, but in many other parts of the world such information is not available or not accessible. There are also not so many people who have the experience to collect such data. And we have experienced ourselves in such less developed countries that simple information is very often already very, very useful. You do not have to set up huge GIS systems there with all kinds of data, but a very simple map is sometimes sufficient. So, crisis information reality is this. This is a photo of the European Crisis Information Center here, of the European Commission here in Brussels, using all kinds of data and sensors and having everything on a large web screen and coordinating relief globally. But there is also this reality. People in the field are working with a paper map. Or that's a photograph from a regional disaster coordination center in the Philippines. They just print out a map, put strings and nodes and put it on a map. So we said that using open data, we have the chance to provide crisis-related information for every place on the Earth. We can do that very quickly, and we can do that at very, very low cost. And that was the start of the Hotspot Mapping service.
So we saw yesterday Ed Parsons' presentation and showing how everyone has a smartphone and it's easy to use all kinds of mapping services on your smartphone. Google, Bing, MapQuest, they all offer types of information that tell you where you are, where you want to go. But the reality is that's for us. The other reality is that in terms, when there is a disaster, potentially you lose the internet connection. The smartphone might not work. And as we saw with the previous pictures, even the emergency responders on the ground still rely on simple paper maps in order to get them there. So what we were seeing as these services, yes, they look great on digital, but the reality is that we still need to sometimes produce paper maps, and this is especially true for those people that don't have the specialty to do it easily or actually know where to get the most updated information. So this is why we decided to come up with the Hotspot Mapper service idea, which is linking open data to produce maps for the citizen. So this is going to be one of the demos that we're going to be demonstrating at the back of the room later, but it's simple interface. Basically, all you need to provide is email, lat long. You actually have a choice of image type, so it's by default color, but if somebody has an inkling as to using a single band or maybe false color, that's also possible now. And just a quick code to make sure that there's not too many machines trying to use the same service. And so what happens is when you use the service, you will receive a message at at your email address, just to make sure that you're a real person. And you just click to verify. You go back, and then basically the system, as long as the verification has run correctly, it says that it's going to deliver within an hour, but in generally it's a few minutes time for processing. And once it's ready, you get your PDF link. which is essentially open because it's all open data, but this is a link that you would be able to share with anybody as well after you produce the map. And so this is the kind of map that you would be able to download and print and use. If you take a look, this is actually Brussels. It's a very recent Sentinel-2 image, and the information is provided there. So this one was acquired in September of this year. It uses some OpenStreetMap vector information, so it gives you the main motorways, which are in red, primary roads, which are the larger roads. This is especially important for access to different areas, and rivers and lakes. I mean, we added those in as natural sort of potential hazards that are important, not only in disaster crisis, but also maybe for planning in areas where this kind of visual information is not available. So this is something that is automated. I mean, there's nothing, we do all the processing in behind, but the person can use it very easily in order to look around what's around them and maybe potentially plan for new, plan for the future.
Yeah, and when we started in 2012 and having this experience from the field ourselves, we thought about potential users, and at the beginning we said, yeah, of course, this is a service that we can offer to people working in living and working in less developed countries, an urban planner, a disaster manager, a regional one, but of course also humanitarian relief organizations, NGOs, and so on. And then you might say, hey, yeah, but we have the Copernicus Emergency Management Service. They also produce such maps. Yes, that is true. But the big difference is when you know how the service is working, you have only an authorized user triggering that service. And then the process is that somebody is starting to sit down to search through archives, finding suitable imagery, putting some vector data on top, creating a PDF just as a reference map before they start doing those delineation maps with flood extent mapping, for example. And all that takes 12 to 24 hours, probably. This is fully automatic and works usually within 10 minutes. Isn't it great? And the other customer that we thought, in the meantime, well, having a basic service, a free service is a starting point. But in the meantime, we had many ideas for premium services that we can sell. Global company risk is a big, big issue these days. We have global supply chains. And for companies, it might be very, very helpful in a natural disaster situation, in a political crisis. Just print a map, show your employees somewhere in a country where the next airport is to get out of the crisis area. These are customers that we have in mind and that we really consider to address and to contact in the follow-up of MELODIES. But that is not enough. We had two partners, we had so many ideas, so we decided to develop a second service. And that's the European Historic Flood Database. Because we are also all used to such kind of photographs, floods. Floods are the most expensive natural disasters, hazards following disasters globally. And it is estimated that there will be an increase of floods globally. That is, on the one hand, linked to climate change, but on the other hand, Thomas explained us the issues of global urbanization. And cities are growing, a lot of planning and construction is done in areas which are rather flood prone, and you would usually not build a house there, but you have the pressure and not space, so you go into these areas. And just as an example, we found figures that the European summer floods of 2013 created a 15 billion cost. And so you see the information about or when you can reduce this amount of loss, you are already a great step forward. So when you want to do disaster risk reduction and preparedness planning, you need, again, pertinent information, also geographic information. And to do risk management, you also need information about the history, what happened before, and will there be maybe a similar event in the future. So you need a systematic collection of such information. But there is none. There are some member countries in Europe, they collect some information. Not all of them. There is no directive or regulation asking them to do that. There are some research-related projects collecting information. Of course, there are insurances they are collecting information, but that is under their ownership. They don't share that for free. So that was then the starting point for the European Historic Flood Database.
And again, one of the things we wanted to do with the European Historical Flood Database is to make it aware to the Europeans themselves actually how much flooding is going on in Europe. I mean, if you just watch the news, you only get a certain piece of that. Currently, we have in our database that we're sharing over 1,200 events across Europe. And obviously, it's important to keep the spatial information, which tells us where it is. And what we're hoping to do is try to tell the full flood story around each event. So one of the applications that we did, which is the public one for people to go and check out, let's say, what types of floods and play around with the information. This is an application with the data, but as you can see, there's different ways of viewing it. So you can go around looking by location, by time, also by type of event. So is it a flood event, a flash flood, or is it because of a storm surge? And the third one also includes the weather information. So the maximum, let's say, precipitation that was occurring prior to the actual event. And so you can play around with all the different screens. This is just the one. But then here in this case, we're looking at the time changes and playing with that information. Another view is the listing of the actual data. And then the precipitation and listing. So, nice slider. You can play around with just going up and down and seeing how many millimeters maximum precipitation occurred before the event. And finally, also you can use different graphs based on location again, time, and seeing how that changes, and either for your own location, in general, about across Europe. The other part of the work that we've done, especially with the help of Athens, was to use linked open data based on the flood information that we had done. So this is about geospatial data integration. Our European Historical Flood Database was included, but they also put in the Korean land cover, some administrative boundaries, and again OpenStreetMap information. And basically the query was to find out which buildings were flooded based on an event that we have in our database. So that for that demo, you guys can go to the Athens demo table as well. And finally, as we were saying, there are users who want more information. So here we know about the event, but what we also want to find out is the story. So how did the flood event evolve at a very precise level? In this case, we're using a recent Yorkshire flood in, I think, last Christmas. And what we're seeing here is the evolution. So before the actual flood disaster was triggered, and we see how it's growing and growing. This is actually when it was triggered by the European Commission and asked for mapping, and then how it evolves after. So in this case, we're showing only a few weeks of the evolution, but we're also able to do that for longer time periods.
Yeah, and then we had we got great feedback from our Partners Board colleague from Giovanna Triani from RMS. She's not with us today, unfortunately. But she said, hey, maybe think a step further. And for building this whole flood story, look also into other data that could be useful for building that. So we also look now, or we are now also able to collect weather information, meteorological information about the global weather system before an event, and precipitation data. We also know now the right sources of openly accessible high-resolution elevation models. We also look into social media and information from the ground. This is this example here, this photograph that you can grab from Twitter, and then we geocode those photographs that we just get a proof how it really looks on the ground. And the other example is from the emergency mapping service. So that is a starting point. We are very, very happy that MELODIES gave us the opportunity to look into these things and to start developing these services. And through the very positive feedback that we got so far, we decided to build a business case around that. So what we are doing, starting from MELODIES, is now the next level is called Inundo, our project name. And that is building on the MELODIES activities, and we going now global, and we want to do exactly what we have shown now before. We want to provide information that is then available to insurances, for example, to do as-if analysis. So what would be the today's loss in case there would be an event like 10 years ago? Or we also think about the validation of natural hazard models, because insurances work all the time with those hazard models and try to calculate the risk. And to validate such models, our information could be very, very useful. And we are very, very grateful because Inundo is already further funded. We get support through the SME instrument, Horizon 2020, to develop this business case. And that's it. Thank you.
Thank you.
Yeah, quite interesting. Yesterday, Jon mentioned that some of the project, or most of the project, also generate some open data. I would be interested in your flood database. Is it something what can be plugged, for example, what we do? Or is it more, let's say, closed database?
No, the one that I'm showing, I mean, if you know how to rip it out, it is rippable. And it would be open, exactly, because a lot of the information, for example, came from open sources, but we have had to clean it up and make it working in this way. Yes, but the idea would be for the European historical database. Yes, that would be an open product. Yeah.
Yeah, thanks for this excellent presentation. However, there are a lot of remarks or questions to make. I'm tempted to offer consultancy to your enterprise. First of all, this is fascinating to have 10 minutes mapping service. But nevertheless, you said communication is breaking down and mobile devices cannot be used. But downloading a PDF, however, needs communication link, which is not broken down. So, and the opposite scenario, if there is permanent communication, is there also a mobile component of your service, which would then include motion and temporal development and so on? And another question is this historic flood service. It's a good idea to link it with the foregoing precipitation. But precipitation is not alone. Of course, you know that the cause of inundation, the underground quality and pre-saturation with water and all such parameters, vegetation, all such parameters are important. So that could be an endless story if you want to inform very globally about events. But I have some more remarks which I keep for the break.
Yeah. Yeah, maybe just a comment on that. On the latter one, we are doing some further research in Horizon 2020, in a Horizon 2020 project where we address exactly that, soil moisture, for example. And we do that with the colleagues from the TU Vienna. They are very, very experienced in that. And with the point of rapid mapping, yes, I agree, but this service is not that much focused on the response, but more for planning purposes.
And I'd like to add, actually, I was surprised to find out that in many cases, dropping pamphlets and things like that from the air is actually still a very used tactic during events. So normally it wouldn't be, let's say, the locals that would print it, but somebody in the relief organizations close could print it out, the hundreds of copies, and they would just distribute it as needed to those people in the area. Yeah. So it's not, I wouldn't expect somebody in Africa to have a printer next to them and be able to download it and print it up. It's really for the organizations that are using it for the relief efforts. Yeah.
Okay, thank you. We're going to have to. No, we don't have digital service right now.